Hello, my dear students. Welcome to my first lecture on continuous signals and linear systems, the Tripoli 703 course. In this lesson, we will start with the basics on signal, the definition of signal, also the classification of the signals, the major classifications, and also some of the important parts like graphical representations and properties of signal. So let's start. Signal. In the first line of definition we have seen here, a signal is a function of one or more variables that conveys information about some usually physical phenomenon. What kind of thing it is? The thing it is the information. The information should have to be carried or conveyed in such a medium, and it should have to be carried in a form of a signal. In a form of a signal. That means signal is an attribute of conveying information. So a signal is a function of one or more variables. Basically, in communication engineering or continuous signal and linear system courses, basically we take the function as a function of time. The thing is that the signal is a function of time. The time is the independent variable in that section, and the function value itself referred to as the dependent variable. That means the value is dependent on the basis of time, and that should have to be a function, and that should carry or convey information. There are some examples of signals include a voltage or current in an electronic circuit, the position, velocity or acceleration of an object, a force or a torque in a mechanical system, a flow rate of a liquid or gas in a chemical process, a digital image, digital video or digital audio, a stock market index. What I am giving you the lecture, while I am giving you the lecture, it also go through to the process of audio signal. So in the meantime, it is dependent on the time. That is the time. We know that is the independent variable in x-axis, and that is the function of time that we talk about as a signal. If we take the signal as voltage or current, like that, the alternating current, the signal will be look like this. It's like a sinusoidal signal. Is it right or wrong? You know it better. That will be a sinusoidal signal. Okay. What does it carry? If we write here 2 volt, that means that is an amplitude. If we write here the phases of the voltage like 0, pi, twice pi, that means the angular representation of 0 degree, 90 degree, 180 degree, 270 degree and 360 degree. It's like this. Okay. So that is also a physical phenomena that we know, voltage and current. Audio signals are two physical phenomena. While I am talking and giving the lecture with this microphone, the microphone is a transducer that takes the audio signal and makes it to the electrical signal, and then it has been processed in this video. While you listen this with your headphone, the transducer, this electrical transducer will take the electrical signal from your PC or laptop or mobile phone and give you the audio signal in your earphones. So that is a signal. It's a signal that is and that will go through to a time also. That's the attribute of time, or it's a function of time. So my dear students, it's very much easier thing, signal. Now coming back to the point, the classification of signals. So we took three big criteria to classify the signal. First of all, here you can see in the slide the number of independent variables. That means if it is one dimensional, that means audio. It can be multidimensional as image. That means there may be audio, video. In image, you can see there's two dimension. How that can I represent you? Just keep an eye on that. A signal with one independent variable. That means that is dependent on dimension, the dimensionality. Okay. In audio signal, if that is an audio signal, it depends on a single variable, time. So it is one dimensional signal. But when you watch a picture, when you watch a image, it's not dependent on one dimension. It depends on two dimension at least. If it is 2D object, what you have seen into your PC, laptop, mobile phones, or any other display display devices, sorry to say that, display devices, there are two dimensions, X and Y. The image is on the card. There is the image. If it's an image here, that is X and Y, two axes are there. It's like a rectangle formed in your picture beam, two-dimensional. If it is three-dimensional object, that is known as 3D object. That means it has an x-axis, y-axis, and z-axis, and show you the three-dimensional view on this. My dear students, there are another example of multi-dimensional signal, video. Video is not only the two-dimensional, but it also carries the dimension of t2. The time is the fourth dimension, and it also creates the video signal. So from the dimensionality, that means the number of independent variable. As we know, if it is a function, that will be a function of time, or that will be a function of x, y, length or breadth. That can be a function of x, y, z, and t2. That can be a video. Okay. So the second part is the continuous or discrete independent variables. A signal with continuous independent variables is said to be continuous time. That is voltage waveform. Just look into it. That is a voltage waveform. In each of the section that you have, that you can see here, if it is a voltage, if it is a voltage waveform or current waveform, anything, in each of the time being, you have a value. There is no break. There is a continuous value. There is no break in this value. In each time period, you have the value on it. It may be 0, it may be 2 voltage, it may be 1.5 voltage, it may be anything else, but it has a voltage or any kind of signal in each time. There is no breakage, there is no discontinuity in there, so it is known as continuous time. If it has discrete independent variables, so it is known as discrete time signal. What is discrete time signal? You can see some of the signals like this. In such time it falls there, in such time it rises there, then again falls, then again here is there is an signal. So this kind of signal has a breakage, has a time lapse on each signal. So these kind of signals are known as discrete signals. Okay, I will discuss later on it.